do now is actually some examples of something called dimensional analysis. And dimensional analysis is just really a conversion problem. And I know that you did some conversion problems in ninth grade, and they're very similar to what you probably did there. The difference being that you're going to have maybe a different chart. This is how your textbook and a lot of other textbooks kind of present our metric prefixes. And so I really just want to show you how we use this chart in order to complete our conversions using dimensional analysis, which is the one that kind of uses the fraction lines. So the first thing we're going to do is we are going to convert 14 meters to inches. And I'm going to do this using the equalities that are shown here, because these are the equalities that you are going to be expected to use on quizzes and tests, and I'm going to expect to see the work in the form that I'm showing you today. Yes, I realize you could Google any of these equalities and you could very easily get an answer, but the answer is not really what I'm as worried about. It's the process, because what we're going to be working towards is stoichiometry, and stoichiometry is basically a chemical conversion, and it's kind of one of the cornerstones of any chemistry course, this idea of quantifying matter. If you do not understand how to use dimensional analysis, you're never going to understand stoichiometry, which is going to be a lot harder for you throughout the year. So again, previewing today, working on it in the next lesson, and really just trying to get this concept in your head so that when we do stoichiometry later, it's a lot easier for you. So what I'm always going to ask you to do is start by writing down the given including the units. And here you can absolutely abbreviate units. Remember, meters would just be the base unit for really any of these prefixes, but it's abbreviated using just M. Once you have your given written down including the units, we use our equalities on these fraction lines. And in order to use this, we take the unit from the top and we put it on the bottom so that it cancels. And then we need to put another unit that we can change our original unit into using one of these equalities. Now, luckily for us here, we started with meters, and meters is a base unit. And by base unit, I just mean one of these metric units that could be fit on to really any one of those little lines. Meters, liters, grams, seconds, things that don't have the prefix in front of them. Since I'm trying to get to inches, what might benefit us is to look at the end where we're trying to go and see what our pathway would be to get there. So if I look at all of these units that I'm allowed to use, you might notice that inches can be very easily turned into something like centimeters. So if I think in terms of my end goal is inches. I know that inches come from centimeters, which means I can turn my meters into centimeters. This isn't going to work in 2 steps or 1 step every single time, but it's definitely a way to plan your problems. It's something to try. So here I've got meters going to centimeters, and then I've got centimeters going to inches. And then I use my sheet of equalities to figure out what numbers go on each line. So if I'm using any of these charts, what I need to remember is that the 1 goes with the prefix, and then the 10 to the number goes with our base unit. So you see these little itty bitty lines that are on each of these? You're going to put the same base unit on both. So I could say 1 centi equals 10 to the 2, negative 2 like here. 1 centi, 10 to the negative 2. I feel 1 centimeter equals 10 to the negative 2 meters. So you just put the same base unit on both the lines from the chart. So 1 centimeter is 10 to the negative 2 meters. And then over here, 1 inch is 2.54 centimeters. I put my units in based on what canceled, and then I put my numbers in based on my equalities. The thing on top has to be equal to the thing on the bottom. I couldn't say 1 centimeter is 2.54 inches because that value isn't the same. A centimeter is about that big, an inch is about this big. 2.5 of these equal 1 inch. Once you have it written like this, then we're going to put it into our calculator. And you guys probably learned multiply everything across the top, multiply everything across the bottom, and then divide top divided by bottom. That absolutely works. Or you can work left to right, which is what I usually do, and I would just put in my calculator the number And then if what I'm looking at doing to it is on the top, I multiply, and if it's on the bottom, I divide. So I would type this as 14 divided by, and then I would actually record the 10 to the negative 2 using that E button that we talked about. So that would be E negative 2. And then, again, the number's on the bottom, so that's divided by 2.54. So in my calculator, I would put 14 divided by E negative 2 divided by 2.54, and that would give me an answer of 551.18. If you remember significant figures, I would round this to 2 significant figures, which would just be 550 inches. And if you don't remember that, that's okay. That's another lesson further down our line here. Again, we're just previewing this idea of setting up our dimensional analysis and using our chart and calculators to get our answers. So let's do another example, and we're just going to do a couple of them together until you sort of get the idea, so that when we look at the next lesson where you're actually required to do these on your own, you're good to go. Let's look at one that actually just sticks with metric units. If I want to convert 0.125 liters to microliters, micro being that little funny mu sign there, I would start by writing down my given, and then I would put the unit from the given on the bottom. And again, I'm lucking out because this includes a base unit. And a base unit, liters, the things without the prefixes, can be used in any of these equalities. So I can literally just look for micro and use that equality. It says 1 micro equals 10 to the negative 6. And there's a line here and a line here. And remember, I just fill in the same base unit on both. So 1 microliter equals 10 to the negative 6 liters. Well, the liters is on the bottom, so the 10 to the negative 6 goes there, and then the 1 is on the top this time again. I'm in the unit that I wanted to be in, so I go ahead and put my equal sign. And then I can just put this in my calculator as 0.125 divided by, since it's on the bottom, E negative 6, and I would get my answer of 125,000 microliters. Now this is kind of a big number, so it's completely appropriate to use that scientific notation and record the number as 1.25 E6 microliters, which again just takes care of getting rid of all of those 1, 2, 3, 4, 5, fifth microliters. Takes care of getting rid of those non-significant zeros. So that's 1, 2, 3, 4, 5 spots to get it so that there was only one number in front of the decimal, 1.25 E, and then the 5 tells us how many spaces we moved it. 1.25 E to the 5th, or times 10 to the 5th microliters. And again, please, please, please do not freak out if this is a little bit fast for you, because we're going to spend more and more time with it. This was really just to preview for you. The next example I'm going to do is going to look at 455 nanometers to millimeters. And here's an example where we don't have a base unit that's by itself. You see our base unit is meters. Well, in both places it has a prefix in front of it. We're still going to rewrite our given including our unit. We're still going to put our unit in the bottom, but this time because the unit already has a prefix, we can't go directly from one prefix to another. We actually have to go through the base unit. So we are going to go from nanometers to meters using this guy right here. The 1 is with the prefix, 1 nanometer. The exponential factor for nano is 10 to the negative 9th, and that goes with our base unit. And if we stop now, we would be in meters, but we actually want to be in millimeters. So this time the meter goes to the bottom, and we use our other, there he is, equality here. 1 milli something equals 10 to the negative 3rd of that thing. The 1 goes with the prefix, the exponential factor goes with just the base unit, and in our calculator we would type 455 times e to the negative 9th divided by e to the negative 3rd. Because this was on top we multiplied, this was on the bottom we divided, and when we do that, our calculator is going to give us the answer, probably in this form. But since this is a really small number, it would be another good time to practice our scientific notation. So we move the decimal 1, 2, 3, 4 spots. And I would probably write this answer as 4.55 times 10 to the negative 4th millimeters. The other thing that I just wanted to quickly preview with you guys are units that are either squared or cubed. And this is the last example I'm going to do today, again, just so that you can kind of see it, and then we'll practice it more later. Let's say we're starting with something like 3,200 millimeters, but this time it's an area, not just a length. So it's actually millimeters squared. If I want to convert that to something like our base unit of meters squared, I'm still going to start by rewriting my given. And I'm still going to put our given unit on the bottom. But what you're going to be really tempted to do, which is not what we need to do, is you're going to be really tempted to look just in this chart and say, well, I know that 1 millimeter is 10 to the negative 3 meters. 1 millimeter is 10 to the negative 3 meters. And then you're going to be like, oh, wait, no, that was squared. And just leave it like that. But what you have to remember is that that equality is only true for the first dimension, which means that when we cancel this out, it would actually only cancel out one of the millimeters, not both, not the millimeters squared. If you want to square a unit and an equality like that, you absolutely can, but then you also need to remember to square the actual numbers. If you square the unit, you need to square the numbers that made it the equality, which at this point, for some of you that are going to get kind of lost in the math, it might be easier for you to actually say, okay, 1 squared is 1, and 10 to the negative 3 squared, well, when you square an exponent like that, you're really just multiplying the exponents. So negative 3 times 2, this is now just 10 to the negative 6. And it might be easier if you actually rewrite it like that before you attempt to put it into your calculator. So then we would be in meters squared, which is exactly what we wanted to be in. So we could just type it into our calculator as 3,200 times 10 to the negative 6. And we would wind up with our answer of 0.0032 meters squared, which we could write as 3.2 times 10 to the, or E, negative 3 meters squared. So you're actually going to have lots of practice that combines the three things we just went over. You're going to have practice doing the English to metric units. You're going to practice just converting metric units using these prefixes and the 10 to the whatever exponent factors. And you're going to have some practice doing either squares or cubes, but that's going to be over the next day or so that we're really going to practice it. The purpose of today was just so that you could preview it. If you want to get ahead of the game, you can actually absolutely do some of the examples in your student learning map, or you can actually jump ahead in the textbook and start doing the practice problems or lesson review questions, and I can look at any work you need me to look at to make sure that you are on the right track.